So let us see in this session trends in atomic radii and ionic radii. So the variations in the atomic radii and the ionic radii. Let us see that. Now, when you see that from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc, out of 10 elements, scandium, titanium, vanadium, chromium, manganese, still this regular decrease in their atomic radii. But from scandium to copper, it is consistently very constant values atomic radii. But from copper to zinc, it is again it is decreases. What is the reason of variation in the same period? This is called period in the same horizontal. Horizontal row. Is called as a row is called as a period. So in this period, there is some variation. It is increases means from left to right it is increases or decreases. But here it is not like that. We all know top to bottom in a particular group, all the atomic radii or ionic radii increases, but from left to right in a period, it is automatically decreases. We all know that. But in this not gradually decreases, there is some variations. From scandium to manganese, it decreases, but from manganese to copper, it has comes to no variations. It is constant atomic radii. Again, it is a copper to zinc. It is a gradually decreases, they said. That is called trends in atomic radii and ionic radii. Now let us consider this. There's a nucleus. Red color is a nucleus, and then one shell, and then there are a lot of shells. We have chosen only last shell and the penultimate shell. Before the last shell, that's what I have taken. That two shells. So NS shell is called ultimate shell. That is called valence shell, and N-1D is called as a penultimate shell. So the electrons are filled or entered. So all the electrons are entered only progressively into the d orbital, d subshell. So transition series move from left to right. Atomic radii decreases. Second and the third transition series nearly same because due to the lanthanide contraction. Here as lanthanide contraction. Let us see that. So here it is 3D series and 4D series and a 5D series. Here like this we are getting most probably it is merging to each other. As the atomic number increases, number of protons also will be increases and the electrons also increases. So automatically number of proton increases, nuclear charge increases. So it increases the nuclear charge and started to drag the electron now towards itself. So atomic radii will be automatically shrink. So does it decreases due to the diffused activity of d block orbitals, which is not screening. The screening effect is very, very less. It allows all the electrons to get inside to the nucleus. So what the atomic radii is, it decreases. This same point is related to ionic radii. So let us consider one question. NCERT question. Why the decrease in atomic radii among the series of transition elements is less when compared to the representative elements. Representative elements means S block elements and P block elements are called as a representative elements, and D block elements is called as a transition elements. So here the additive electrons are entered into the d orbitals, that is called penultimate shell. So in penultimate shell only the extra electrons are added at all. So the atomic number increases, nuclear charge also increases. Why the nuclear charge increases? As the atomic number increases, the number of protons will be increases, number of electrons also will be increases. So if the number of protons are increasing, automatically the nuclear charge also will be increases. So the electron entering N-1D orbital, that is called penultimate shell, increases nuclear attraction of outer electrons, means NS electrons, due to the screening effect. Less screening effect of d orbitals, it allows all the NS electron to get inside to the nucleus. So hence atomic radii decreases. Here let us see scandium, titanium, vanadium, chromium, manganese. Up to this, it is a nuclear charge is greater than the screening effect. SE is called screening effect. Screens the nucleus. So nuclear charge is very greater than the screening effect. So automatically the electrons are get dragged to the nucleus. So the size of the atom would be decreases. So it is a decreases in there. So and then from iron to nickel, it is a nuclear charge is equal to the shielding effect. I mean screening effect. Shielding effect or screening effect, both are same. So nuclear charge is same. So from iron, copper, nickel, the atomic radii is same. Then when you come across copper to zinc, that the nuclear charge is lesser than the screening effect. So what does this decrease? I mean lesser than. Shielding effect is very greater than the nuclear charge. So here it does a increase. So next question, why does the atomic radii of iron, copper, nickel or a same atomic radii in that particular series? You just see this diagram. It is nucleus. I mean here written plus proton is there. The electron in ns orbital, this electron is n minus 1d electrons. So if it is only one electron, I mean penultimate shell, if it is only one or two electrons is there, what happens? There is a, I mean attraction between this electron and the nucleus because the shielding effect is very less diffused. It is a very big room is there. So only two of you in the classroom means you will sit here and another students will sit here means all other places are very vacant only. So immediately what happened? The last row electron will be attracted by the nucleus. So what attraction will be taken out because of lesser number of electron in the penultimate shell. Lesser number of electron in penultimate shell. So what that is outermost electron of ns electron immediately attracted towards the nucleus. So what they will get a atomic radius decreases when you see this scandium to manganese up to 5 electron, because supposed to be 10 electron instead of being 10, that is only 5 means nuclear charges are greater because number 1, 2, 3, 4 it is gradually increases 1, 21, 22, 23, 24, 25. So gradually increases by 1 unity only. So 1 electron increases, the nuclear protons will be increases, the nuclear charge also increases. The screening effect of d electron is very less electron only. So it is not what able to protect the ns electron. So what immediately they will attracted by the nucleus, so automatically the size would be shrink. So the size will be shrink means due to attraction, the size will become closer. So what there is scandium to manganese, that is the electronic configuration is decreases. Then from iron copper nickel, then nuclear charge is equal to screening effect because here number of, I mean from manganese, I mean iron is having 26, copper 27 and nickel 28, number of electrons are increasing. Here have 6 electron and 7 electron and 8 electrons are increases in a d orbital means. So what they will, there is a electron repulsion will be takes place. This is called electron repulsion. And d electrons and the ns electrons will be getting the repulsion between electron repulsion. So what it will not allow the ns electron to attracted by the nucleus. So what it is here, what happens now? No attraction, so no shrink, so that electronic config, I mean atomic radius equal by iron, cobalt, nickel. Then afterwards, next question, then zirconium and hafnium, the niobium and tantalum. Comparing these two, zirconium, hafnium and niobium, tantalum, or same atomic radii. So in exam, definitely they will ask you this type of question. You just write the by heart these values: 160 picometer for zirconium and 132 for titanium picometer, vanadium 122 picometer. It is gradually increases top to bottom. It is left to right. It is a decreases. So here 160 picometer for zirconium and 158 picometer for a hafnium. Both are nearly same due to lanthanide contraction. Reason is lanthanide contraction. Next, niobium and tantalum. Niobium 146 picometer, tantalum also 146 picometer. So both are same. This also due to the lanthanide contraction. So what we should write these values. So picometer means 1 into 10 to the 10 to the power of minus 12 meter. 160 into 10 to the power of minus 12 meter, and this is 158 into 10 to the power of minus 12 meter equal to 1 picometer. So 1 picometer equal to 10 to the power of minus 12 meter. So here I have written for a first transition series, second transition series, and last transition series. I mean, no, not first transition series, I'm very sorry. And this first 5 elements and next 3 elements and last 2 elements. here that there's nuclear charge is greater than screening effect, and nuclear charge is equal to screening effect, and nuclear charge is less than screening effect. So first set, second set, and a third set. So first one is a small size and midway, and this is the last one, last element. So last one is nothing but electron repulsion. So